I'm going to be covering today more of the problems that exist with climate change and the solutions that we have ahead of us. I want to start off with my favorite climate expert, Dr. Catherine Hayhoe from Texas Tech University. And she's also an evangelical Christian. And she started off a presentation I saw here in Houston with a very interesting statement. She said, I don't believe in climate change. And kind of everybody in the audience kind of went, whoa, what are you talking about? And she goes, climate change is science, it's fact. My religion is a belief. And it was a really interesting and I think very stark way of kind of just starting us off with the fact that we're talking about facts in science. We're not talking about belief. A lot of people would rather not believe that the climate is changing, but that's not the situation that we're looking at. Now, the other thing I wanted to start off with was an observation. Terry Hershey's husband, Jake Hershey. Many of you may know Terry Hershey. She was kind of the environmentalist, the leader in Houston for many years, very involved in most everything green in Houston. Among other things, a big supporter of urban harvest over the years. And Jake once put his arm around me, at a cocktail party and said, Blackburn, have you ever worried about what happened to the horse and buggy? And I said, I have no idea what you're talking about, Jake. And he said, well, the people that made horses and buggies were the leaders of the economic kind of revolution of the late 1800s. At least some of them were among the most wealthy in the country. And then the car came along and totally wiped out the horse and buggy economy, if you will. And his point was the market can change incredibly fast with different signals and different kind of impetuses that are kind of forcing kind of where the market goes. And I think I keep Jake's message in mind these days as I watch what's happening with climate and particularly climate in the economy, which will be really the second half of the presentation. Nobody thinks much about the horse and buggy these days. Are we headed for the same thing with sort of the internal combustion engine in cars? It's an interesting thought. So the truth about climate change, the climate's changing, humans are changing it. Now, that's not really a controversial statement. Virtually every scientific organization that studies these issues agrees with that. This slide on the right-hand side of your screen, 80 National Academies of Science come up with that opinion. That was from 10 years ago. I mean, this is not a disputed issue. The United States, fourth national climate assessment from the Trump administration. Climate is changing, we're causing it. So that's really not a debate issue anymore. The observed change in surface temperature, I mean, this is data. This is recorded over time. The areas in purple have had a change of 2.5 degrees centigrade. The areas in red have all increased in terms of average temperature. The only place that is really blue, or at least the one that's notable, besides actually Texas, which I'm not sure I quite understand, is below Greenland, where the ice is melting and the ocean is cooled in that location. This is from John Nielsen Gammon, the state climatologist of Texas. And basically what it shows is that Texas's temperatures are increasing. They have been for the past 40 years. According to John Nielsen Gammon, the rate of change is similar to what would be expected given global trends, and it appears to be largely anthropogenic and should be expected to continue. Of course, anthropogenic means it's caused by humans. Now, that is the official climatologist of the state of Texas over at Texas A&M with that pronouncement. Now, what I'm amazed at about climate change is that a lot of people have really not seen kind of what all of this means. Now, when you talk about what it means, something to keep in mind, there has to be basically alternative futures and alternative future projections. And what I'm showing over here on the right-hand side, there's kind of a purple there's a line with purple on either side of it. There's a red line with a kind of a reddish color on either side of it. These are different climate projections in terms of emissions in the future. Carbon dioxide emissions, other greenhouse gas emissions are tied to climate change, to the warming of the atmosphere, to the warming of the temperature. And these different scenarios are about different amounts of carbon dioxide or carbon dioxide equivalents being released to the atmosphere. And so when you see RCP, I think was it 2.8, 4.5, 6.0, and 8.5. Those are four different scenarios of carbon dioxide emissions. And basically, the amount of change is related to the amount of emissions. That is a key aspect of all of the work that is being done in climate. So here you see the average surface temperature change is going to be much higher in degrees centigrade with more emissions, and you reduce that by keeping the emissions down. Same thing with sea ice extent. I mean, under this scenario, we eliminate summer sea ice up in the northern hemisphere by 2050. Now, it doesn't affect Texas a lot, but that's a big deal up in the Arctic Circle area. One that does affect Texas a lot is ocean surface pH. The pH is also affected by the amount of carbon dioxide in the atmosphere, the CO2 coming into the ocean, and then the change of pH of the ocean waters. And with the higher emission scenarios, the pH of the ocean waters goes up tremendously. Those have huge effects. The other point I want to make is climate models must include a human factor. All of these little charts here, there's a purple area and a pink area on each one of these little charts. Purple is only looking at natural factors to explain the change. Pink is adding in human cause factors. To me, this is the graph that truly explains that humans are, you've got to have a human factor to explain the changes that we're seeing. And we'll go over that in several different ways. Coastal waters of the Gulf of Mexico are increasing. This is the Western Gulf. The highest temperatures are getting higher. The average temperature is getting higher. That's just data. In terms of the ocean heat content, that's going up. In terms of the global sea level, that is going up. These are observed changes. Carbon dioxide levels we know are going up. This only takes us up through about 2010. We're over 400 now. It's the exact same pattern. It changes at different times of the year, but the trend line is absolute. And if you look at that in reference to the last 800,000 years, these numbers are just off the charts high. Totally different than anything we've seen for a long time. Now, I want to talk a little bit about statistics. The chart at the top is from Moscow, and this is where Dr. Ron Sass over at Rice came and made a presentation in my class. And he used this chart to begin to talk about the fact that there's no way to explain the temperature in 2010 in Moscow. It's so different than their averages. It's way off the end of the chart. They also had high incidences in 72 and 2001. And the bell curve, which is that big slope that you see, that white line, I think I can probably outline it with a white line that goes up like that, is the bell curve. Basically, we work off of averages. And we assume that this statistical distribution, particularly with things like temperature, you can depend on 50 years worth of records, 100 years worth of records to give you a good indication of what your weather would be. So based on that, you can begin to set up percentages of times that things would occur. And I'm really interested in this area down here off the bottom of the curve. So to put this chart larger, I'm interested in focusing on this area over here. This 2% chance means that basically it ought to happen once every 50 years. A 0.1% chance means it should happen about once every 1,000 years. That's where we get something like the 100-year flood event. So when you hear people talk about a 1% event or the 100-year flood, statistically, it's out here on the edges. And it's a point that is defined by all of this other data, and it's a relatively rare occurrence, but I mean, things happen beyond it, but not very often. If you look at what we've had here with rainfalls, we've got Tropical Storm Allison, we've got the Tax Day storm, we've got Harvey, and the Melda, which came in 2019, is right there between Allison and Harvey. Now, that is not a common standard statistical distribution pattern. That is an aberrant pattern. And that is a pattern that indicates change. Now, I once saw a presentation by a person, a stock analyst, and they use these curves in all sorts of different applications. And he put these two lines up, and he put TBD. And I was trying to figure out, to be determined, that doesn't make any sense. What does TBD mean in this context? And turns out, he said, there be dragons. The edge of the bell curve is the spooky area. This is where your truly aberrant events occur. Those are the events we've been having. This is the reality of climate change, that we will be seeing more and more aberrant events. Now, with these different climate change scenarios, there's going to be changes in the average. There's going to also be changes in the extreme events. I just talked about the extreme events. The changes in the average are really spooky. If we have a low emission scenario, we're still going to see an increase in temperature. That's up on A, that's the one on the left-hand side. And that shows, somewhere between a degree and a degree and a half over most of the world, and that's in degrees centigrade. If we don't change the way we're emitting, the modeling projections here show that by the time you get to about 2081 to 2100 time period, the end of this century, we're going to be looking at, probably an average of 5 to 7 degrees, something like that, maybe 3 to 5 degrees centigrade on average. With the northern hemisphere having tremendous increases. The rainfall, I'm not going to talk as much about because I don't think we've got quite as good a handle from the models in terms of long-term averages, but there will be certainly changes in those long-term averages. Now, this is the one that, as a Texas resident, you might want to pay some attention to. Top slide. From 61 to 79, we had less than 20 days per year where we got over 100 degrees centigrade. 100 degrees Fahrenheit. If you have the low emission scenario, by 2080, 2090 time period, it's predicted that there'll be 20 to 30 days over 100 degrees Fahrenheit. But if we have the higher emission scenario, we'll have 100 to 120 days over 100 degrees Fahrenheit. Now think about that. You know how hot it is. I mean, we're in the middle of the summer here in Houston, and it's plenty hot. I saw 99 degrees on in my car yesterday. But think about 100 to 120 days a year over 100 degrees Fahrenheit. I would be surprised. I have asked many audiences I've made this presentation to, how many of you have heard these scenarios presented? And very few people have heard these scenarios and what the results of these scenarios are. And in particular, I'm talking about, down in here. Now, this says 2080 to 2099. Something to keep in mind here is this change will be gradual toward 2099. This change is happening now. It is something that is ongoing, and it will be a stepwise process. And one of the things I am looking for are good intermediate images, because it seems like a lot of people see this slide and go, oh, well, that's 2099. I'm going to be dead and gone by the time that comes along. Except that this is occurring today, and it's the stepwise function. So what? What does all of this mean that we're going to be looking at this type of change? Well, the catastrophic events are going up and will continue to go up. The only thing that is not changing are the geophysical events. They're staying pretty much steady. But our meteorological events, which are is in the dark blue here, the hydrological events in green, and then the climatological events, extreme temperature, drought, forest fire events, are also increasing. Cumulatively, though, that trend is just going up and up and up. What am I most worried about? Hurricanes. This is going to affect hurricanes. This is, I mean, this is the Texas coast. It looks like a bowl of spaghetti there. The Texas coast gets hurricanes. We've always had hurricanes. This is Ike coming in 2008, the last really big storm that we've had in the Houston area in terms of storm surge. Harvey coming in, actually, Harvey's not on this chart, but Harvey came in down here. I'll show you more about Harvey, but Harvey was a rainfall storm. Ike was a surge storm and flooded everything from basically the east side of Galveston Bay all the way back across to Grand Isle, Louisiana, and wiped out the Bolivar Peninsula. And there was certainly flooding on the actually exposed southern shorelines of the west side of Galveston Bay from the back circulation. Now, hurricanes are essentially heat pumps. Hurricanes get their energy from the ocean. And if you look at the fact that we've got a hotter ocean, we've got a situation where we've got a hotter ocean, we've got a hotter atmosphere that holds more water. All of the factors are there to increase the severity of hurricanes. And this is something called the power dissipation index anomaly. It's just simply showing that the potential strength of hurricanes, the power, the intensity of these hurricanes is going to be increasing over time. It is not a good scenario for us. Now, this is Hurricane Harvey and the path of Harvey. It's kind of interesting to look at it in light of what we're seeing coming off the satellite now, and then it'll show you these different systems coming off the coast of Africa, and then basically they wander across the Atlantic. Harvey was actually named on August 17th. It degenerated into a tropical wave, kind of disappeared, at least as a really identified storm. It's just a mass of rain coming across, went across the Yucatan, and then reformed as a tropical storm on August 23rd. It became a Category 4 hurricane almost overnight. It was the fastest forming hurricane in United States history because of the heat of the Gulf of Mexico, because of these factors we're talking about. Then it came into the coast and stopped. It's almost unprecedented for a Cat 4 hurricane coming ashore to actually stop. But there was a high pressure system over here and a high pressure system over here, and it basically blocked the storm moving in. And so it kind of wandered around. And of course, those of you that were here during Harvey know how much rainfall that we got during Harvey. The point being, this was a climate change influenced storm in many ways, certainly more than a single way. We had a conference over at Rice at the Speed Center in February of 2018. The consensus is that there will be increased rainfall in the Houston area due to climate change, and that the future storms that we'll see will be bigger. We've got to be honest about this. This is absolutely critical to the future of Houston. Now, this chart is a bit detailed. This is our current 100-year rain and 500-year rain. We use the 24-hour rainfall event. It's kind of what we work with. So right now, officially still, 13 inches in 24 hours is our 100-year rainfall event. That's what the 100-year maps, 100-year flood maps that are out there are based on this. We're redoing our maps based on this NOAA Atlas 14. And this is a report that came out at the end of 2017. It includes Harvey data. And it identifies 17 inches of rain in 24 hours as our 100-year storm, and 25 inches of rain in 24 hours as our 500-year storm. But now look at these storms that we've had. Imelda was 21 inches in 24 hours. Harvey was 25 inches in 24 hours. Tax day 17, Allison had 28 inches in 24 hours. There's a storm in October that 94 that had really 21 inches. I mean, I'm not real comfortable with 17 inches as our 100-year storm, but that's what all of our new planning is based on. We are not looking forward in our analysis of these storms. I think that's a major problem. I think that, frankly, there's a chance that everything we're designing now will be obsolete almost as soon as it's built. We're basically driving using our rearview mirror. And this is something that's just pervasive about climate. We've got to be able to look forward. And right now, we keep looking backwards. We keep looking at the statistics, and we don't take the more recent statistics and try to tease out of them what the future is going to look like. There are various reasons, many of them political, about why we do what we do today, but it is not good for us. Again, Catherine Hayhoe talks about driving with the rear view mirror, and she says in West Texas, you can probably do that pretty safely for a while, but she says, I think it's coming into, I don't know, Plainview, one of those West Texas towns. There's a grain elevator right in the middle of the road, and the road swerves around it. And if you're driving in your rear view mirror, you're running right into that grain elevator. Well, we're running into some grain elevators by using our rear view mirror. And I mean, it's just kind of where we are, and we've got to get better than this. We can be better than this, but we've got to trust science, and we've got to trust modeling. Now, this is my favorite slide of this whole presentation. This marker was put up down in the Clear Lake area, down by NASA, after Hurricane Ike. And it marks how high the water would be in a Cat 4 storm and how high the water would be in a Cat 5 storm. This sign lasted about 2 months and was removed because of complaints by the real estate industry. Hard to sell houses with those markers around. So we took the markers down. Now, what that tells me is it's more important to sell real estate than it is to protect the people. We've got to change that. My vision of the future is it's more important to protect people than to sell real estate. That is something that is pervasive in our society. There are economic effects of the information that I'm talking about. We have to be honest about it. Sea level rise. The average number of amount of sea level rise that we're told probably is still, I guess, probably the prevalent view, 1 to 3 feet of sea level by the end of the century. That's going to be basically the area shown in green here. Mr. Hansen from NASA, or formerly of NASA, probably the best, one of the best climate scientists I've ever run across, James Hansen from NASA, thinks that that's low. He was joined with about 16, 17 other climate scientists. They're predicting 3 to 10 feet as a reasonable amount of climate increase to have, or sea level increase to have. That would cover the area in yellow. If we had 10 feet of sea level rise, that begins to get pretty serious. We're talking about losing, I would guess, probably 6 million acres on the Texas coast. Now, that is not the commonly accepted view right now. 1 to 3, I would say, is the commonly accepted view, but sea level rise is a big issue. Now, when we talk about sea level rise, it is already beginning to be observed. That area in brown that you see there is the number of days where basically tidal flooding is beginning to come inland significantly with the really high tide events. I smile when I look at this because there's a bunch of us looking at this at Rice, and we couldn't figure out why that graph leveled off. This is the number of days where essentially high tide flood events would be occurring down in Port Isabel. And that's like where you'd have local road flooding, things like that, with frankly, the tide coming up. Well, the reason it levels off is it has reached 365. That's every day. Miami's already having this problem. We're going to really begin to see this kicking in strong on the Texas coast in the next 10 years. By 2030, we're going to see about half the days in the year where we're going to have severe high tide events. It's coming. It's happening. You know, this is my point about that chart that talks about, well, look, you know, it's out here. Well, that's 2060 when all that. Yeah, but this is happening in 2040. That's 200 days a year we're going to have problems. This is about 2030 where we're going to have about 125 days a year. This is happening over time. Things like bird migration are affected by climate change. It's back to the so what. All of these on the left-hand side, all of these top dots are the furthest north recording of various nesting birds. We're seeing expansions northward. This is the breeding area of the summer range of the Baltimore Oriole, expanding northward over time. It has from 2000 to 2020. It's going to continue to do that. This is coastal marshes along the Texas coast. They're going to need to migrate inland because the sea level is rising. If we don't have the ability to migrate these marshes, we're going to probably drown them and lose them. That's a so what. Flounder. Flounder require a certain number of days. I think Bob's going to talk about the plants and what's required temperature-wise for certain plants to germinate and to thrive. Well, the same is true with animals as well. Young flounder are becoming harder and harder for the net data of Texas Parks and Wildlife to pick up. We're just not seeing the replacement. Flounder need a certain temperature, a certain low temperature, to be reached and maintained for a certain number of days in order for the eggs to basically become fertilized and to begin to mature. It's just not happening like it has in the past and should in the future. pH of seawater, I mentioned that earlier. As the pH drops, it's going to be harder and harder for the calcium carbonate chemistry to occur like it has been. The expectation is we may see fewer hard shell organisms like blue crab, oysters, brown and white shrimp. The larger so what? We're going to see regional strife, if not outright war, caused by that. There's going to be caused by climate change. There's going to be environmental immigration. There's going to be large-scale economic changes. And one might also anticipate large-scale spiritual changes as well. I'm not going to talk so much about this, but it's an area that I find incredibly intriguing. If you look at the vulnerability to climate change, the areas in red are the most vulnerable. Malaysia, Southeast Asia, India, Bangladesh, Africa are the areas shown in red on this map. But it just simply makes the point that certain areas of the world are going to be more vulnerable to climate change than others. If you throw in the ability to adapt, the current financial situation of the countries, their ability to respond, you begin to see a little different map. Certainly Africa is incredibly impacted. Probably the center part of Africa being one of the most serious of these areas. Pakistan, Afghanistan, some of the Middle East begins to show up. We know about the fires in Australia. In terms of sea level rise, we've got cities all over the world that are extremely vulnerable. I think this is again James Hansen from NASA talking about the cities that he thinks are most at risk around the world. And Houston does not show up here. Houston's inland. I mean, we're at elevation, I think my house is about 45 feet. It's not bulletproof from a sea level rise standpoint, but it's not as vulnerable as a lot of areas. But there are many places around the world that are incredibly vulnerable to sea level rise, particularly. And here they're noting New York, Boston, Miami, Virginia Beach, New Orleans, Tampa, St. Pete in the United States, and of course many other countries around the world. Water stress. Look at the United States, southwestern United States, central United States, definitely expected to be water stressed. The droughts will be just as bad as the floods and the big rainfall events will be. The droughts are on the other side of the bell curve. That's what we worry about, is that bell curve. We're seeing the action at the edges of the bell curve. But look at the Middle East. If you think we got problems in the Middle East now, I think that they will only get worse. Um, and this shows where there is extremely high water risk areas in the world. And I mean, just time after time after time. Let's see, number one is Qatar, 5 is Iran, 4 is Jordan, 3 is Lebanon, 2 is Israel. I mean, right there in the center. So water as an issue is huge. And then you've got just generally the ability of states to withstand that change. This is a slide showing fragile states, again, emphasizing really the vulnerability of the central area of Africa. The point here is that there are going to be changes that will occur in the United States that many of us are not aware of. They're going to affect us daily. There's also going to be major geopolitical issues arising from the changing climate. And that's something that we really don't know much about and don't talk about. So now I want to talk about what should we do about it? What's going to happen? What action should we take? Now, I put this slide in here because it makes me smile for one thing. I have tried to talk about climate change in Houston for many years. And I have found that if I start off a conversation about climate change with this slide, I can talk to anybody about climate change. Now, some of my environmentalist friends kind of get offended a bit that I'm talking about climate change and money. But in the Houston business community, this slide will keep people's attention because there are huge financial implications and there's huge economic implications. And I think we will see a different economic system emerge because of climate change. On the other hand, sometimes if we use words that are more comfortable to talk about an uncomfortable subject, it's easier to have a conversation. Money is something that a lot of people understand, and I can talk about climate change and money and not lose an audience. And it's something I've just found very interesting about having a discussion about this. Bob may have similar luck talking about gardening and growing things and climate change. So much about climate change is uncomfortable. And certainly the implications that I'm going to be talking about are going to be harsh. The Paris Climate Agreement was signed in 22nd of April in 2016. This is the chart of where we have to be. And basically, it's about becoming carbon neutral by 2050. That's essentially the global policy right now. As a global community, we are shooting to become carbon neutral by 2050. Now, that has been basically formally adopted in the Paris Climate Agreement. The United States signed it. President Trump is withdrawing the United States from the climate agreement right now. But the global community is on a path to be carbon neutral by 2050. Most multinational corporations either are or will become carbon or committed to being carbon neutral by 2050. This is where things are going. It's not something we've talked about a lot in Houston. Now, the oil and gas industry has got tremendous pressure. There are tremendous forces that are working on the oil and gas industry right now. There's public opposition. There's financial issues about it, their future. There's moral opposition. There's legal opposition. They're facing continuing pressure all the time. And it's beginning to have a real impact. This is one of my favorite slides. Again, this is Pope Francis meeting with executives from the oil industry and meeting with also executives from the investment community that basically underwrites the oil and gas community. Pope Francis came out with the encyclical that he put together about faith and climate. And it is one of the most incredibly revolutionary documents, really. Google the Pope's encyclical on climate change, and you will find an incredible document of really a changing view from the religious community of the concept or the issue of climate change. He is probably the most adamant, outspoken of the religious leaders in the world about climate as an issue. And in this case, he was meeting with the leaders of the oil and gas and investment community, basically telling them they needed to do something about climate change. I would have loved to have been in that meeting. I have to admit, that's one meeting where I would have loved to have been a fly on the wall. When I first started working on a lot of this, I was back, been working on these climate issues pretty seriously since about 2010. And I was told when BlackRock Financial makes a move, things are going to start changing in the oil and gas industry. Well, BlackRock Financial made a move January 14th, 2020. And what BlackRock announced was that they will begin to exit investments in coal production. They will begin to introduce funds for investment that ban fossil fuel stocks. And they are going to begin to vote their shares. And these are, this is $1 trillion plus investment company, to vote against corporate management who aren't making progress on fighting climate change. Now, that is a huge, huge change in BlackRock. And like I said, this is what I was told to watch out for. When BlackRock moves, this whole the conversation is going to change. Well, the conversation is changing. Now, when I first started as an environmental lawyer back in the 70s and all through my career, the economy that we've been working with is one that takes natural resources, manufactures various types of goods, various types of services. We consume those, and then we throw away the residuals, the waste products. That is part of our economy. That is what we call, or what I call, the linear economy. It's a straight line economy. Now, the economy of the future will be different. This is a diagram by Herman Daly, my favorite economist. And first of all, he shows the economy as a subset of the ecosystem of the earth. That is an important concept. Herman Daly was the working at the World Bank as an economist, and wanted to publish a report that showed the economy as a square within the larger circle of the ecosystem, because his view was that the economy had to basically live within the limits of the ecosystem. And he was fired because he insisted upon this diagram. I mean, this is a heretical document on one level because it suggests limits to the economy. On the other hand, what it talks about is energy and matter coming in, and energy and matter, if you will, coming out of the economy. And it puts recycle in there as a kind of key piece of the equation. And that becomes a huge piece of where we're headed. The linear economies on the left-hand side: extract, produce, consume, and throw away. And the new economy of the future, the circular economy, is the economy that you see on the right. And the transition from a linear economy to a circular economy will be the hallmark of the 21st century. This is the response to climate change, is to change our economic view of how we do things. To me, is almost a profound, I mean, something as simple as this diagram is profound. Something as simple as that diagram that Herman Daly drew is profound. We've got to live within the limits of the ecosystem. That means we've got to protect the atmosphere. We've got to take that carbon, which is the carbon cycle is shown over here on the right-hand side. The Earth has natural cycles. We take carbon dioxide out of the atmosphere with plants and with various types of prairie plants, marsh plants, trees. We take carbon dioxide out of the atmosphere, put oxygen back. That carbon dioxide gets either put into the system or perhaps goes back into the atmosphere, but it's a circular system. Same thing's true with precipitation. We have a circular system of evaporation and precipitation. Nature is full of circles and cycles. The closer we can link the human economy to the natural economy, the economy of nature, the better we're going to be. And part of that is getting our carbon cycle back into balance. We are out of balance on the carbon cycle. We're headed toward putting it back into some sort of much better balance. Our carbon emissions, our carbon dioxide emissions are in excess of 35 billion tons on a global basis. China is, I think, ahead of the United States now in terms of the total amount of emissions. Of course, China has over 1 billion people. The United States has over 300 million people. So there's a difference in per capita consumption. But in terms of just sheer volume, China and the United States are the leaders. The point being, we've got to get that down to zero. We've got some work to do by 2050. And how are we going to get there? Again, simplicity. I keep emphasizing sort of some of these simple concepts. This is what's called the wedges concept. It comes from Pakalo and Sokolov, who are two Princeton scientists that published this in Science magazine back in 2004. What you see in front of you is how you solve climate change. Those wedges each represent 1 billion tons of carbon, which is 3.5 billion tons of carbon dioxide. CO2 weighs more than carbon does, so a ton of carbon is the equivalent of 3.5 or 3.65, I think, billion tons of carbon dioxide. So to avoid 5 billion tons of carbon, about 15 million tons of billion tons of carbon dioxide emissions, switching to renewables is a huge thing. Renewables can make a big difference. Nuclear fission is identified as an option. There's no CO2 emissions, at least from the production of the nuclear energy. There is from a lot of CO2 associated with the facilities themselves and with the processing of the materials. But from the actual nuclear process itself, no CO2. Minimization, energy conservation, energy efficiency, huge benefits. Fuel switching is switching from coal, for example, electrical production, switching from coal to natural gas. And then finally, carbon capture and storage. And they identify both natural storage and CO2 capture and storage. But what they have identified are basically chunks, large chunks of emissions that can be removed simply by avoiding, minimizing, or removing, capturing, and storage. I just love that as a beautiful kind of way to at least begin to think about, well, we can do this. You know, these are just, step 1, step 2, step 3. And we have scope 1, scope 2, and scope 3 of our emissions. When you hear about carbon footprint, when you hear about the emissions of carbon, this is how you think about it. Scope 1 is what you actually put out. If you have a personal car and you drive it, you are having scope 1 emissions. You are emitting carbon dioxide. If you have a natural gas furnace in your house, if you heat your pool with natural gas, when you turn that natural gas burner on and burn natural gas, you will emit carbon dioxide. If you're a company, a refinery, a chemical plant, they are direct emissions from boilers from various sources. And then there's all sorts of vehicles the company owns. Scope 2 are the emissions that all of us have from purchasing electricity. The grid of the state of Texas has an energy or a carbon emission profile. All of us participate when we use electricity from that grid. Many of us try to buy green energy, and that's great, but you're still going to be emissions from the grid. You've just invested in renewables, and that feels good, but there's still emissions associated with the electricity you use. The really interesting one is scope 3, and I'm not going to spend a lot of time on it, but there's both kind of upstream and downstream indirect emissions. For example, all of us, or many of us, have investments of different types, a retirement account, um, perhaps savings accounts, or stocks. Well, what stocks are you invested in? Well, there are emissions associated with the stocks you're invested in. There are emissions that are associated with all types of activities, both above and beyond. And this is where something called supply chain gets involved in the process of carbon thinking, because companies are now looking at who are they buying things from and what does their footprint look like. And then downstream, people that are buying are looking at, well, what carbon investment am I purchasing? And so you're starting to see carbon accounting going all through the economy. And the carbon footprinting business is expanding, but it's more importantly, I think, than that, carbon footprinting is the starting point for becoming carbon neutral. Because first of all, you have to identify what your carbon footprint is. Then you identify back to those Pacala and Socolo and those wedges. Once you calculate your footprint, you identify what can be avoided, what can be reduced, and what can be removed and stored. And that is sort of the process toward becoming carbon neutral. Now, this is not anywhere close to the full list of companies that are committing to carbon neutral or renewable commitments. In the last 6 months to a year, this slide is from about 2 or 3 years ago. And these were some of the early ones. The country of Norway's committed, the province of British Columbia. The companies shown are all involved, but it has gone far beyond these companies now. Business-wise, there is a revolution going on in terms of the movement toward carbon neutrality. Carbon neutral cities. There's a Carbon Neutral Cities Alliance that's out there. These are cities that are committed to becoming carbon neutral by a certain time period. These cities may well become the premier locations for new economic development in the 21st century as carbon neutral thinking begins to emerge. On the other hand, Harris County, at least back in 2002, which is the last time I have found this compilation, was the top emitting carbon dioxide county in the United States. The United States is a major carbon emitter. Harris County is a leading, or the leader, in terms of carbon emissions from the county itself, not to mention the emissions from companies that are headquartered here. Now, this is where business is headed. Business as usual is shown at the bottom. A regenerative circular economy is shown at the top. You will not believe the number of companies that are beginning to put circular economy as a goal for the 21st century. Many of the plastics companies particularly are very, very interested in circular economy. But there's all of these steps in between getting to the circular economy. You lower your carbon emissions, you have carbon neutral operations, but that's your scopes 1 and scope 2. That's what you actually produce. You have carbon neutral products where you're really thinking about who you're selling to. Shell is committed to being carbon neutral in terms of its customers by 2050. That is huge. I'll show you more about that in a minute. Carbon negative, where you go beyond your current emissions and actually take more out of the atmosphere than you're putting in. And then regenerative is where you're truly restoring energy and material cycles, and you have created the circular economy. Now, Bobby Tudor is the new president of the Houston Partnership, and he made a blockbuster of a speech in the first part of this year. And he has a view of Houston leading the energy transition. And I just put this up there because it emphasizes what a different conversation. And certainly we were having this conversation before COVID hit. And with COVID coming, the conversation has continued. So this is a conversation, it's a harder conversation because of the economic impacts of COVID. But the need for this conversation has not gone away. Very interesting situation. I would have thought that there would have been a real drop off, but I'm seeing more interest today in August of, or July, end of July, 1st of August of 2020, than at the first of the year when Bobby Tudor made this presentation. His idea of Houston is that we will lead the energy transition. We're committing to lower carbon emissions. We're talking about new technologies to address the dual challenge of meeting global energy while lowering the world's carbon footprint. Leverage Houston's strength in natural gas. Lead the development of carbon capture, use, and storage. That's the removal of carbon dioxide, either from the stack or from the atmosphere. And be leaders in energy efficiency, conservation, and sustainability in smart city technology. Now, that is the conversation that is occurring publicly by the leader of essentially the business community in Houston. And that is a conversation that frankly did not occur in 2019 or 2018 or 2017. So this is a huge change. Now, there's some pretty serious emissions that are headquartered in Houston. These are 15 companies that will remain unnamed that have basically between themselves 538 million metric tons of carbon dioxide emissions. Then this is only scope 1 and scope 2. So 15 companies with a strong Houston presence represent over 500 million metric tons of emissions. Those are directly. Now, I picked on ExxonMobil. This is public information. They have 120 million or so in direct emissions. If you look at their customers and what their customers' combustion product is, they're about 610 million. So there's about a 5-fold difference between direct emissions and scope 1 and 2, and then scopes 1, 2, and 3. So if you go back to this 538 million metric tons and multiply by 5, you're talking about 2.5 billion tons of carbon dioxide emissions that are represented by just 15 companies that are very strong in the Houston region. If Houston gets behind doing something about climate change, if the Houston business community gets behind doing something about climate change, it can make a huge difference. Carbon capture and storage technology has been where the oil and gas industry has been committed for years. That cost, the lowest we've run across is $60 a ton. It's more like $100 a ton for average and gets up as high as $130, $150 a ton. And it's very hard to, frankly, get the scale of removal that you need. Carbon is priced. Carbon dioxide emissions are priced around the world. This is a dashboard that's maintained by the World Bank. In California, right now, there's a market at $15 a ton. British Columbia is about $35 a ton. You get over into Europe and they tax carbon. And in Sweden, it's over $100 a ton for carbon dioxide emissions. Switzerland, Liechtenstein, Finland, Norway, France, Iceland, Denmark, all of them are taxing carbon. The voluntary market on carbon, yeah, there's some of it up in around $25, $28 a ton. Right now, the voluntary market for carbon has been slow to develop, but it's evolving. Now, when I talk about voluntary markets and I talk about technology, this image is of the technology. This is what it looks like when you capture carbon and you try to put it down into the soil. So you get carbon dioxide out of your flue gas, out of the gases that are coming through processes. You come through separators and you basically pump it down deep. This is the $60 to $130 a ton carbon. However, there is another alternative for capturing carbon, and it's a wonderful technology called photosynthesis. Something Bob Randall knows a whole lot about, something Urban Harvest knows a whole lot about. Trees, native plants, wetlands, they're wonderful. Basically, carbon dioxide can be captured and stored in native systems. And that's what I'm spending a lot of my time on these days. Um, Here is just an example. Carbon dioxide comes into a tree as photosynthesis. There is CO2 that's released, there's oxygen that's released. But over time, carbon becomes stored in the wood material of the tree. Some of the trees I've seen, I think a live oak over 30 years or so will sequester about 5 tons of carbon dioxide um, in the life cycle of the tree. Um, Carbon dioxide comes into marsh grasses and goes down into the soil of the marsh. Some comes back to the atmosphere, but net, conservatively on the Texas coast, we get 2 tons an acre from our marshes per year. The root system of native prairie grasses are fabulous for putting carbon dioxide into the soil. And that is, I think, probably one of our greatest opportunities for carbon capture is to expand the native prairies that we have. That root system is essentially a carbon pump. Carbon dioxide comes into the plants by photosynthesis and gets pumped down into the root system. The roots put sugars out into the microbes that are in the subsurface. And basically you build your soil over time with organic carbon. Again, something Bob can talk a whole lot about. Now, in the work that we're doing, we think about putting carbon in the soil through the root system you see on the right-hand side, kind of like growing potatoes. It's a crop. We want to see a lot of ranchers particularly become carbon farmers. With row crops, we got to be careful. Plowing releases a lot of the carbon that's stored, but there is a future in carbon farming. This is the key area of the United States. That's kind of that central prairie grassland. We think has huge potential. A lot of that is row crop country. And we grow a lot of row crops for cattle feed. We'd like to see probably the feedlot business begin to disappear, and a lot more grass-fed beef and a lot more beef-friendly or a lot more bird-friendly native prairies. Again, this is sort of that prime area. In yellow, you see the pasture and range areas. In brown, you see the cropland. But we think you will see probably more pasture and range, particularly over here on the backside of the Ogallala Aquifer. They're beginning to run out of groundwater. We're talking about native systems that can survive basically and thrive with the natural conditions. Now, climate's changing a bit. There'll be changes, there'll be perturbations, but there is a latent seed stock out there that we think can really be both found and regenerated. Carbon neutral driving, we think, will be a thing of the future. If you paid $20 a ton to a farmer for each ton of carbon dioxide they put in the ground, that'd add about 20 cents per gallon, $100 a year, and you could drive carbon neutral. If a company offered carbon neutral gas, would you buy it? This would be what it would be talking about. Carbon neutral refinery. 150,000 barrel refineries, kind of a small to average size refinery here on the coast. They generates about 4.6 million tons of carbon dioxide each year. Take about 2 million acres on the Texas coast at a couple of tons per acre. If you're talking a ton an acre, which is maybe more reasonable for native prairies, 4 million, maybe 2% of Texas. If you took all the customer emissions in, rather than the 6%, if you did a ton an acre, probably be more like 12% of Texas for a single refinery. Take some land, but you're talking about paying landowners money for putting this carbon dioxide into the ground and storing it. With ExxonMobil, I used them earlier, if you take that 610 million tons of CO2, again, at 2 tons an acre, you're talking about a quarter of the U.S. grazing land. We're talking about a lot of land, but there is also a lot of money that we're talking about. Now at Baker Institute at Rice, we are developing a standard for basically carbon transaction. We are setting up a system that will enable buyers and sellers to come together and pay landowners, basically, where companies like the big emitters can pay landowners, ranchers, farmers that are doing various types of practices will also be able to qualify, and paying them to store carbon dioxide in the soil. That system, we're about to put out a publication in a couple of weeks that will be essentially a summary of the standard that we're developing. We will be setting up a certification entity that should be established over the course of the rest of this year and early into next year. And we hope to be seeing transactions under this standard in early to mid 2021 on a commercial level. There is a working group that's been developing this standard. These are the members that have agreed to allow their names to be used publicly. There are many others that are participating that would just as soon not have their name publicly linked with it yet. They're kind of waiting to see how it all kind of develops out. But it's a very interesting cross section. Everything from the King Ranch to Parks and Wildlife. We've got a lot of participation from New Mexico. We've got some national groups like Ducks Unlimited and Audubon Society that are working with us to create this standard. There are companies, Valero, Sprint, several oil companies that would prefer still to not be named. Just helping to develop this, wanting to see this system get started. The idea of carbon exchanges came out of originally the Green Think Tank at Houston Wilderness, at least my involvement with it. We brought those over to the Speed Center at Rice University. There is something called the Texas Coastal Exchange that exists now. I think Lily has put that up on the chat. Check it out. That's probably the most vibrant exchange right now. America's Wetland Foundation basically asked us if they could rip that idea off, and they set up a variation called the Louisiana Coastal Exchange. The Texas Hill Country Exchange, we're about to get started with as a nonprofit. And then there's a private company called Soil Value Exchange that comes out of this Rice University work. And that's looking to take all of these concepts commercial and work with landowners to help them package this for sale. The target is really the cow and pasture range. But look at this livestock feeding. This is basically how the United States land use is kind of parceled up. This has no geographic importance. It's really important as a percent of the United States land area. But look how much we are using for growing feed for livestock and feed exports. That is a really interesting area that I've got my focus on. If that land use were transformed back into native grasslands, that would make a huge difference in terms of the carbon footprint. So my last slide is basically that there's 6.5 billion tons of carbon dioxide that are emitted by the United States. There's about 1 billion that is tons that are available for carbon dioxide storage in the soil. There's not room for everybody to store their carbon dioxide in the soil. It's likely to be the least expensive long-term solution to removing carbon dioxide from the atmosphere and storing it. It's going to be a little bit of like a game of musical chairs. Question is, do you have yours yet? And individuals can also participate in this system. Again, I would refer you to Texas Coastal Exchange. And thank you. That's pretty much what I've got. Lily, you want to take back over, or Carol?
Thanks so much, Jim. Appreciate it. And Carol, if you want to moderate what questions have come up.
Sure. Just to let everybody know again, you have a Q&A box at the bottom of your screen where you see the menu icons. We have 2 questions submitted so far. Thank you, Karen and Megan, for submitting your questions. Also, another option is that you can post your questions in chat, and our audience members, we have 50 folks with us, 54 participants total. You can post your questions in the chat just like Karen did, so that if you have resources, you can also chime in and answer in the dialogue on chat. So thank you, Jim. Thank you for that talk. And one of the first questions we have is related to schools and school districts. And so I'm going to turn the question a little bit to tap into your expertise as the leading environmental lawyer in the state of Texas. Because Karen is asking, how would you apply these same concepts of circular economy solutions to school districts? And do the solutions lie in policy or grassroots efforts?
Well, I think the answer is both. The grassroots efforts are important to get the policy thinkers thinking in a particular direction. So I think certainly the input from the parents, certainly the input from the taxpayers of the district can make a difference. The ideas I'm talking about are not ideas that are necessarily well known or well accepted. So I think a lot of it involves some education and understanding how the circular economy the type of thinking might be better reflected. I think part of it is everybody ought to at least be able to talk about what their carbon footprint is. What are they doing about it? I mean, just again, it's not, and a lot of times we approach these things, but why aren't you doing this? It comes as an attack as opposed to, look, let's work together and figure these things out. We're working with some churches, we're working with some different organizations, really from the standpoint of just trying to understand what is what are the issues, how do we work through them together, as opposed to we versus they, or you're doing it wrong. You know, we tend to be accusatory rather than working together in sort of a community sense, as opposed to, I mean, and lawyers are the worst. I mean, we get paid for proving someone else is wrong. This really isn't about right and wrong. This is about a different way of thinking, a different way of approaching. And so I think so much of this is in how you approach it and how you set it up in collaboration. You've got some tremendous talent at the school district in the teachers. And a lot of these teachers are probably much further along than the administration has a clue. But I think trying to tap into that expertise and at least figuring out what's out there. But again, I think it's attitude. I just think we've approached I'm an environmentalist. I'm a card-carrying environmentalist, and I think the environmental community has done this wrong in a lot of ways, and that it's always been, we're right, you're wrong. It's almost like a conversion has to take place, and that's not it. It's about working through to solutions in my mind, and I think that's kind of the key.
Thank you for that. Yes, working through solutions together and as a community effort. So as you said, a lot of teachers are further along and incorporating carbon footprint studies within their classroom. We also have environmental conservation groups that I can also post into the chat a little bit later or send as a resource to connect teachers to those other resources. Now, we have a question from Megan. How do you see incoming artificial intelligence, machine learning, automation impacting the overall climate change topic? Can these technologies help us make sense of the problem and provide solutions?
Well, I'm no expert on AI, in a technological sense. I mean, certainly companies are doing all sorts of alternative futures analyses. So, there are algorithms being developed and perfected where you can begin to say, okay, if I go down this path, and if I do this, that a lot of if-then scenarios can be evaluated very quickly using computer-related kind of both techniques, and then the learning part of that is trying to come in and then perfecting those various algorithms to come up with the fit. That is a sophisticated approach that's going to be used by a lot of these companies. There's a lot of data to crunch if you're a company. A lot of issues come up, and so there's a lot of room for machines to help us a lot. But I don't want to. I think to emphasize the machine is to de-emphasize our personal responsibility to both, commit the machines to do the learning on these issues. I mean, basically, we've been in denial about climate change as a community, as a nation. for a long time. I mean, one might argue we're still in denial at the state or the national level with at least some of our leadership. And, that's what's got to change. I mean, we've got the tools to figure this out if we get the commitment to figuring it out. I think that's the point. I mean, AI can help, but I think the real problem is back with our human intelligence and getting our intelligent humans to actually act like they're intelligent and do something about it.
Mm. Yes, just again, working together, and our leadership is so key and important. So who we vote for, and also community action on the local level. So I'm going to look at the chat because we have a few questions in. Just when you post in the chat field, when it says to, you can select the audience. So make sure that you select all panelists and attendees to post to all, because right now it is set to default for panelists only. And so we have Susie Shapiro who posted some resources. I shared that to all in the chat. And Karen does have another question about architecture. And so it's architectures in school. So the guidelines for green energy design and architecture, she has attended some workshops and she doesn't see a model or standards included for schools. So what would be a solution for a circular economy and working together to integrate those two?
Well, I'm not sure that I've seen a blueprint, for schools specifically myself. I mean, what I'm finding is that we have to search. I mean, I've got a group of students that have been working with me this summer, and we've been looking at things like apartment complexes. We have been looking at things like various types of businesses, and you almost have to develop these resources. I mean, I'm not saying they're not out there, but they're not necessarily easily accessible. Some are, some you have to pay for access to. And so, yeah, it would be lovely just to get the architects here in town. I mean, there's some fabulous green architects here in town. They really understand these issues. They know what they're doing. To get them to begin to put out some guidelines and some recommendations. There are really, in terms of standards out there, I mean, there are precious few standards in terms of like what we should be shooting for, what are your best practices. I think all of this is evolving.
Mm-hmm. It is evolving. I know within HISD, the Houston Independent School District is working very closely with the National Wildlife Federation. And so the National Wildlife Federation has developed standards for teachers and schools to look at a rubric to grade themselves on either gold, platinum, silver levels of being green and sustainable. So within their architecture and also within their curriculum and programming. So I see another question from Carolyn. She says, how does a landowner begin the process of soil storage, carbon transaction for transformation of property? Well,
I mean, I think that where we're coming from with at least the Baker Institute standard is that measurement is a key. And right now, we don't think there are sufficient kind of really good scientific studies out there to make a definitive statement about any particular soil type or kind of geographic area, because there's a lot of variation depending on rainfall, depending on kind of the management styles. So we're looking to measurement, and measurement costs money. So it's going to be larger tracts that we're going to start off with. I think as we get better with this, we're going to improve the technology for soil carbon testing, and we will develop methods that will make it much more accessible for every landowner. Now, what landowners can do is they can begin to manage their properties in different ways. I mean, one of the common things we see is overgrazed properties. That's one of the things that certainly you'd want to try to change, is because you want to enhance your native vegetation. You want that native root system, which is really what we see as premium. There are grazing techniques, regenerative grazing, adaptive multi-paddock grazing, some of the concepts that Alan Savory kind of perfected many years ago. Those types of things, is what we really recommend as sort of the best management practice for for ranch lands or for lands that are large enough to be able to utilize those concepts. You know, for lands that are for very small tracts, we're looking eventually to expand to those. Probably harder with grasslands than it is with individual trees, frankly.
Also, I did want to share with the audience Artist Boat, which also does a lot about education on native plants in the marshes that sequester carbon within their roots. So that's also a resource in addition to like this larger land. I do have a question about that because in the slide for feed export, you said that that was most likely one of the target areas that would have a great impact, because raising crops to export, do you think that sort of pasture raised farming, raising livestock to include native grasses would be a way to integrate sort of a circular solution within living within the means of the environment?
Oh, absolutely. I think that's exactly what we're suggesting, is that is the solution for the future. If you think about just like a kind of current kind of mechanical agriculture, which I know is not what Urban Harvest is about. And I mean, Bob can talk, I mean, any of you three can talk forever on these subjects. But if you just think about using the tractors to plow, the hydrocarbons that you use for that, pesticides, herbicides, fertilizer, all of the different things that kind of go into modern row crop agriculture. And you do all of that to grow corn or grain to then feed to livestock, to fatten them up before you slaughter the livestock. And if you change that to the livestock feeding on the natural grass, what we are seeing in the data, and there is a definitive study coming out of Arizona State University, and they're going through peer review now. A lot of this data will be coming out later this year and early next year. But that the methane emissions from cattle that are grass-fed is going to be much lower, we believe. The sequestration of carbon in these, particularly in regenerative grazed ranches, is going to be much, much higher than even you get with your standard native prairies. They're replicating the action of the buffalo on those landscapes. It's a very interesting kind of way of looking at grazing and working through. And what we're seeing is, if you think about how many emissions there were with this kind of a mechanical ag alternative, and where we're headed with this more natural economy, we're going to be restoring hydrology. We're going to be restoring the carbon cycle. We're going to be removing the carbon dioxide emissions. I mean, that is the circular economy. So yeah, very much so, Carol.
Mm. Well, thank you. And so we now have a question from Betsy Longoria. So Betsy, oh, I'm sorry.
I'm sorry, Carol, to interrupt you. Somebody, I think Andrea had a question on restorative justice. Do you want to take that one? I think that one's before Betsy's.
Okay, is that one in the chat?
Yeah. How do you, Jim, consider what's going on today, particularly and in terms of global poverty? How can you use the circular economy to have restorative justice and work on global poverty to get away, to get people to work together? So many people are struggling just to survive and are not empowered to work on this problem. Rather than appealing to just large landowners, how can we create a personal sense of responsibility?
Well, I mean, I think that is going to be one of the much harder issues. I mean, to some extent, we are looking for almost the easiest place to start, which is working with the large emitters and working where we've got the biggest ability to take carbon dioxide out of the atmosphere. Beginning to integrate that in any kind of a concept of environmental justice, kind of two ways of looking at it. I mean, the first way I look at it is the lower income community is going to be most heavily impacted across the world in our communities by climate change. So anything that we're doing to address climate change, first and foremost, is an environmental justice solution. So I think just first and being, I think if you look at, and it may not be perceived this way today, but in my assessment, that is the largest long-term threat to the lower income community is the climate change we're looking at. If you look at Northeast Houston and Harris County and their impact from Harvey and then from Imelda, there's people that are still living in houses that have black mold inside them. I mean, there are people that have not had a chance. You know, in some areas of town, you see people restoring their houses. They're elevating, they're elevating them up higher. So, we've got people that are still living in these houses that have not been totally repaired. So there are certainly different levels of issues, but those rainfall patterns, if we don't solve the flooding problem in those neighborhoods, if we don't buy out a lot of the houses that are deep in the floodplain. Now, to me, those are the solutions that you can come in at the neighborhood level and implement. How do we get individuals to buy into the circular economy? How do we get the individuals to appreciate these if you will, almost subtleties when they're having difficulty making their daily bread and being able to survive? I don't have the answer to that yet, but it is a absolute critical issue that we've got to address and incorporate.
Mm-hmm. Yes, thank you for that response. And Lily, thanks for chiming in on that question. That's a very important question and relevant. And also for lower income communities, access and work in the food system and strengthening our food system and supporting local farmers is all part of the circular economy.
Absolutely.
Yeah, so it is 11:30. We are going to have to wrap it up because we're at the end of our session. Betsy,
we can go over a little bit. So those people who can't stay on, sorry about that, but we'll continue to answer questions for those who are on for the next 10 minutes or so.
Sure. Okay. So we have a little bit of time for more questions. Betsy's question relates to public lands. How do we look at our public lands differently? Do you see any changes that could be made in federal agencies such as the Bureau of Land Management? So going back to larger picture.
No, it's an excellent question, and I mean, one of the things one of our member groups at Baker Institute is the Western Landowners Association, and they have a lot of landowners that are leasing land, for example, from Bureau of Land Management. And most of the work that we've been doing, at least in the way we're structuring the standards at the Baker Institute, is that we require landowners to make commitments of no plowing, no subsurface disturbance for a period of 10 years. That's going to be renewed each year that there's a transaction. The federal government owns that land out on much of the, 50% of the western United States, something like that. Huge federal ownership out there. Of course, Texas is private property, but for the most part. But once you get into New Mexico, Colorado, Utah, moving back out to the west, you've got a lot of federal lands. I would think that the BLM, the Bureau of Land Management, changing its rules, beginning to recognize long-term management plans for sustainable grazing, for regenerative grazing, and then incorporating that into essentially their lease structure is going to be one of the real key things. But we're going to be setting up a separate working group at Baker Institute just to address the problem of Western lands and these really the commitments that a lessee can make and begin to participate in this process, because there will be quite an interesting market, we believe, developing here that's vibrant. And if we could offer ranchers an additional $30, $40 an acre of income, most of them would do handsprings to be able to get that additional income, really with essentially practices that are also conducive to raising beef. So, I mean, we're not talking about one or the other. We're talking about layering benefits on top of each other to try to maximize income for the ranchers that are participating, and ultimately for the farming community that might be able to participate in this.
Okay, so I'm looking at the chat. I think that has answered most of the questions that have been submitted. I believe that's all the questions that we have at this time. Again, thank you, Jim, for joining us and presenting all of this valuable information. So hopefully, I'm hoping that we can continue this as a series, and we do have the next part, which will be Bob Randall.
Thank you so much, Jim, and thank you for everyone who attended.
Well, good. Thank you for having me, and I hope everyone enjoyed it.